In this lecture, we're going to be able to cancel items that are queued to be built at a building. Let's go. In Unity, down here in our building in progress container, we can see we've got these 5 buttons. We can also see they are a prefab variant based on our action button. So they're inheriting this UI action button script. That's quite helpful because they look and behave very much the same. They've got that same background image. An icon that's going to be displayed will show the item that's going to be built as that icon. And again, in the future, we'll show a tooltip. So we're going to want to set it up where when we click on this, it cancels that item from the queue, which we can see is going to have a couple of different variants there. Because if we cancel the first one, we're going to want to cancel whatever progress is going on there and start on the next one. But if we cancel like the third element, then that shouldn't impact the progress of the currently building one. It should just shift all the other ones over. So let's hop into VS Code. In our Building Buildings UI, we can see that we're going to need a reference to those 5 different buttons. At the top, let's add a serialized field, a private UI action button array, and let's call it unit buttons. Now, whenever we call enable for on the Build Buildings UI, we're going to want to enable these buttons for the items that have a queue, and we're going to want to disable the ones that do not have an item in the queue. Do you have any thoughts on how we might attempt that? Well, in here, right after we assign that delegate handler to the onQueueUpdated, I'm going to define int I equals 0 and go for, and we don't need to define a variable here because we're going to use that I, and this is going to look a little bit weird, but it's going to make total sense once we do this. So we'll just skip defining a variable there. We'll say I less than the building.queueSize I++. And in here, we're going to want to do unit buttons index by I.enable for, but we can see here now we have a problem. The UI action button is an IUI element of action base to Unity action. We really want to take in whatever's in the queue here, which presents a new problem that we need to be able to access the queue now. So we want to enable this for maybe building.queue index by I. And then we want to do something here as a handler to, let's say, update the queue. We want it to look something like this. Our first problem is that this UI action button doesn't accept these types. And that's where we're going to introduce this lecture's challenge. Go ahead and create a new class, the UI build queue button, and that's going to be an IUI element. And I don't want to give you too much direction on this. We just talked about a little bit of how that should be. I want you to really think about what does this button need based on what we saw on our UI action button. So the hint here is that it's going to work very similar to the UI action button, but it's going to have slightly different types. So I really want you to think about how can we do this UI build queue button, think about those types, and go ahead and implement that button. I know this is a little bit more challenging than some of the other challenges. So if it takes you a little bit of time, that's totally all right. Pause the video. Once you got that where you think it's going to work correctly, I'll see you right back here and we'll walk through it together. All right, welcome back. I really like these more open-ended ones because it makes you think about it a little bit more and really gets the juices flowing there. We want to start in our UI components. We want to make that new class, the UI build queue button. Let's go ahead and put that in our GameDevTV RTS UI components namespace and define it as a public class, UI build queue button that extends mono behavior and implements the IUI element. And what types do we need here? Well, we're going to need to know the unit SO that is queued. And the action should probably be a Unity action. We'll go ahead and implement that interface. It always gives us disable first. We'll push that down to be the second one. And much like our UI action button, we're going to want a private button. And on awake, we can do button equals get component button. Exactly the same as before. Mine pulled in the wrong namespace here, so make sure you're using the Unity Engine UI button. And we know we're going to need a reference to that icon. So we can make a serialized field, private image icon. We'll just move the button down below that. And maybe in awake, we want this to be disabled by default. That might be a nice enhancement that we do also over here on the UI action button. Let's come back to our UI build queue button. And before we get into enable for, I'm actually going to go into this split view by just dragging that UI action button to the right side of the screen so we can see both of these classes at the same time because they're going to be very, very similar. Let's start by just copy pasting enable for and disable from UI action button over to the UI build queue button. Now, if we inspect our set icon, I think we're going to work a little bit different than this because we're not going to expect that a unit SO does not have an icon. So this might make this a little bit more simple. We can go ahead and close that UI action button. I don't know that we need to keep looking at this. I don't think we need all of this logic over here on the right side, set icon. So that's where we're going to start deviating. Let's go ahead and just remove that call to set icon because we're not going to define that function in this class. And we'll do that in both enable for and disable. Then our button.onClick.addListener in the enable for function, we just need to rename that to callback instead of onClick, because that's the name of the parameter that we get here. So we've enabled our button, we've added that callback onClick, and on disable we do the inverse, button interactable false, and button onClick remove all listeners. Now we just need to set up the icon. So maybe we can do icon.gameObject.setActive true, and then set the icon.sprite to be the unit SO's item dot, oh no, we don't have a sprite yet. So in the unit SO, we can attach a field, serialized field, public sprite icon with a public get and a private set. Then back in the UI build queue button, we can say icon.sprite equals the item.icon. And of course, on disable, we just want to do the inverse, icon.gameObject.setActive false. That's all we were looking for in this one. There was the extra step there if we had to attach to our unit SO this icon that might have tripped you up a little bit, but the rest of this looks very, very similar to that UI action button. And I hope this makes total sense how we ended up here. Now in our building UI, we can migrate our type over here, our UI action buttons, to a UI build queue button. So our enable for should start working once we can identify our queue and we can create some kind of update queue function. Let's start with the base building. And I've said this a couple of times, we really don't want to offer direct access to this queue because that gives us the ability to manipulate this anywhere, even if we make it a private set. So I think up here at the top, we can do a public unit SO array, much like what we did here in our delegate. So we can offer the queue as an array. And if somebody mutates that queue, it doesn't really matter. It doesn't impact our base queue. So we can add a new field, again, an expression bodied property with a public unit SO array queue with a fat arrow to building queue.to array. So anytime we try to access this base building.queue, it's going to convert our queue to an array and give us a copy of the queue, which means nobody can accidentally modify our queue. That makes sure that we retain the encapsulation that we're looking for. So problem number 1 is solved here. Now we can enable this unit button for this particular item in the queue. And now for this update queue. Well, we're going to need a mechanism to cancel an item in that queue. Well, that sounds like the base building needs to offer the ability to cancel an item in the queue. So let's head back over to base building. We've got build unit, which basically wraps the enqueue function with a little bit of logic. So we probably want to offer something like cancel building unit. We can define a public void, cancel building unit, and let's say that we want to do that by the index. That seems like the most reasonable way to handle that. Now we need to do a little bit of validation here. So if the index is less than 0 or index is greater than or equal to the building queue count, we can just debug log error attempting to cancel building a unit outside the bounds of the queue, and we'll just early return. That'll indicate that we have made an error in our code somewhere and enabled the player to try to do something they weren't supposed to do. Now, if we have a valid index, we have really 2 cases, and we talked about that a minute ago. Case number 1 is if we are removing that first unit in the queue. For removing that first one, we have some work to do with our coroutine here, and for removing any other ones, it's much more simple. So if the index is equal to 0, we'll just temporarily say, hey, we're going to reset the coroutine. We'll look at that in a second because the second case is much easier. Else, we just want to remove that item from the queue. And here we'd want to do building queue.remove at a particular index. Now the problem is the queue data structure doesn't have that capability. We can only add something to the end and remove something from the beginning. So it seems like we need to either implement some fancy logic around this or sacrifice the benefits of a queue and use a simple list. Because we know it is likely a player may need to cancel items by clicking on the UI, and we have very small queues, only 5, converting this to a list is probably our best option here. Let's convert from our queue to a list. Now when we enqueue an item, we can just say add. We know that add adds something to the end of the list. If we scroll down to the next compilation error, which is in do build units, instead of using peek, we can just get the first item in the list. And instead of dequeue, we can remove at index 0. So we're always just operating on the head here, index 0. That gives us the benefit of being able to remove at a specific index here, which is going to be a pretty common activity. Once we've removed that item, remember that we need to raise our onQueue updated event. So let's go ahead and raise that here in the else block on queue updated question mark dot invoke building queue dot to array. And then let's take a look at our first case. If the index is 0, well, we are going to need to remove at index 0 in this case as well. So let's go ahead and move that up here to the top level. And if the index is 0, then we want to stop the coroutine. Instead of doing like what we did over here on the building UI, where we have to have this private coroutine, build coroutine, start this coroutine, and check if it's running. We don't really need to do that in this case because we know there's only the one, and we don't need to check if it's running. We can just stop it. And we can do that with stop all coroutines. It's just a little bit shorter if we know that we want to stop any coroutine running on this mono behavior. And if we still have something in the queue after we canceled that first item, we can start a coroutine to do build units, which looks like it will invoke our onQueue updated for us here, so we don't need to call it above. But if our queue count becomes 0, we are still going to need to raise that onQueue updated. So we need to add else onQueue updated question mark dot invoke, again, our building queue to array to give back that empty array. Great. Now we've added the ability to the base building to cancel a building unit at a particular index in the queue. And we can also refer to our building queue from any external class. Back over in our building UI, this update queue is going to need to call building.cancelBuildingUnit at this particular index. What we can do here is make an inline function with just double parentheses, fat arrow. And I think we only need one line of code here to say building.cancelBuildingUnit. And the reason we want to do an inline function is because we need reference to this I. We need to know what the current index is. And actually, I'll spoil a surprise for you. If we leave this exactly like this, it's never going to work correctly. It's always going to cancel the last index. If you look at this, can you tell why that is? Well, what we need to provide is a local variable scoped to this iteration of the loop int index equal I, and do building.cancelBuildingUnit with the index. So this index is going to be cached here and provided to this function call, and it's not going to be changing. If we left this at just I, as we increment I and we mutate it over time, whenever we come back to call this, it's going to take whatever the value of I is at that moment, which will, in this case, always be the building queue size, -1. So a little got you with these inline functions. You need to be a little bit careful with what you're referencing up because you can very easily end up in that weird situation and it ends up being kind of hard to debug. Now our unit buttons should be working okay. We're going to provide them the unit SO and a Unity action that will cancel building the unit at that particular index. Now remember I said this a little bit weird. Why didn't we define int I equals 0 right here in the for loop? Well, let's say that we have 3 items in the queue. That means we're going to hit 0, 1, and 2, right? But we have 5 UI building queue buttons. So if we do a second for loop, again, keeping the same I, and go to the unit buttons.length, still incrementing I by 1 each time, we can call unit buttons indexed by I dot disable. So we can iterate this for loop, let's say the 3 times for I equals 0, 1, and 2. We exit there. I is now 2. We'll go for 2, 3, and 4 here and disable those last ones. So that's just a neat little trick with our for loops here. There's one more thing. Whenever we update the queue, we want to do all of this stuff again. So why don't we take all of this code from our enable for, refactor, extract method, rename, we'll call it setup unit buttons. Then whenever handle queue updated happens, we'll go ahead and set up those unit buttons. However, now that we're calling it on every time the queue is updated, it's possible that the unit buttons may not be disabled before we call enable for again. That introduces a potential problem because in the unit buttons, we're only clearing the click handlers on the button when we call disable, which may result in us having multiple click handlers assigned to a single button, canceling more than one unit at a time. So I think to be safe, here at the first line of enable for, we need to make sure that we do button.onClick.remove all listeners to remove any dangling Unity action callbacks on that button before we assign the new one. Let's go ahead into Unity and see if this works correctly. We've done a lot of stuff without really testing it yet, so let's take a look. There's a couple things we need to do in here. For our building queue button variant, we want to open up that prefab, take our UI action button script and remove that, and attach the UI build queue button, hook up that icon, save the prefab and exit prefab edit mode. Then remember our worker SO, we added this icon sprite. So let's go ahead and hook that up, the icon. Let's attach our worker icon. And on our building in progress container, we need to hook up these unit buttons. So again, we'll lock the inspector, select all 5 buttons, drag them over here. We've got all 5 and they're in the correct order. And then if we click play, select our building, we can see that we probably, when we select this, want to set the progress of the progress bar to be 0. If we build a unit, we see the progress bar is going and we see our unit shows up here on the button. Great. If we build 3, we can cancel those. That's still looking good. However, if we start building more after we've canceled some, our progress bar stops working. It seems like our class just totally forgot about a coroutine. So if we leave play mode, come back to our building UI, there's a weird nuance when working with coroutines. In here, on enable 4, we assign build coroutine to be start coroutine. Our update unit in progress will execute. And whenever the queue is updated, we will potentially reassign this. And whenever this is disabled, we set the coroutine to be null. However, if this happens to just execute and come to the end of the queue, so the queue size has fully exhausted, we still don't set our coroutine back to null. So the last step of our coroutine here should be assigning itself to be null. That doesn't automatically happen for us. Basically, the scenario we saw was this coroutine got started, and after it completed, we had to reference this coroutine, and it was just a completed coroutine. It wasn't set back to null. Now, we also saw that we want to set the progress bar, set progress to 0 when we enable it. That's going to make it look a lot better. One more time, back over into Unity. We can click play, select that building. That progress bar starts at 0. We can build a couple units. Let's watch that progress bar go. Great. The second one, it's completed. And if we build one more, great. Progress bar is working perfectly. And if we cancel that first one, we'll see it restarts. So all of the use cases here seem to be working correctly. A little bit more complex than you might have initially thought, but I hope you had a lot of fun making this work. And when you're ready, I'll see you up on the next lecture.